Yeah, hi everyone. Nice to meet you. Thank you first of all to Techno Days for giving me and all the other great female talents out there the possibility to present our talk. I really think it's a great chance to grow the diversity in the tech industry. A few words about myself. So I worked for over 5 years in the 3D printing industry and learned there about the potential of biomaterials, and writing since 2019 in my blog Circular 3D about biomaterials and the sustainable impact of 3D printing. And end of last year, I founded together with my co-founder Circuiteria. This is a digital platform that connects all stakeholders along the circular economy and helps customers to find the right sustainable material for their product. We are producing more and more fossil plastic, and this harms our environment and health with plastic waste and plastic burn emissions. This plastic problem is a linear problem of our fossil-based economy. We produce plastic products from oil and gas, consume them, and then throw them or burn them away. In fact, 99% of the plastic things we buy are trashed within 6 months, despite all efforts to consume less, reuse, and recycle. For example, the worldwide recycling rate is only at 14%. One main reason for this is because plastic packaging are contaminated with food, and that can make up to 50% in overall waste. And this plastic problem only gets more serious because right now we are producing already 380 million tons every year, and with the rising world population and increasing demand, this number could be soon 4 times of that. And yeah, by 2050, it is estimated that the CO2 contribution of plastics will be already at 15%, and we will have the same amount of plastic like fishes in the water. So we can spend years cleaning up the oceans, but 8 million tons of plastics are entering the sea each year, and the largest 3 best known beach cleanups can tackle just 0.5% of that. It's important to realize that the garbage that comes out of your house is just the tip of the iceberg. So even if we could recycle 100% of our waste, it doesn't get to the core of the problem, as 70 times more rubbish is created up front when producing the things we consume afterwards. So clearly, it's a system in a crisis, and it becomes clear that instead of dealing with the symptoms, we have to focus on the root of the problem and change the way we produce these things. And there's clearly a better way. The circular economy concept. It is defined by principles that design out waste, keep materials and products in use, and regenerate natural systems. And circularity is a huge business opportunity, as you can see here. So it is estimated that alone in the next 10 years, it could generate a value of $4.5 trillion. Just to give you an idea, this is 20% of the annual GDP of the United States. And for the circular economy, we have a role model. This is our nature. It has been dealing with dynamic change and complexity for over 3.8 billion years and has developed a circular model that is working very effectively. Here you can see nature's circular model. So plants provide food for animals. When the animals die, they provide food for their decomposers. Animals' tissue is decomposed into soil nutrition. Soil nutrition serves as food for plants, and the circle continues. Simple, but very efficient. But if we want to understand in detail how nature is achieving such a powerful system, we need to look at the foundational principles, the so-called biosphere rules. The first one is power autonomy. So every transformation from a raw material to a finished product requires energy. And in nature, it's done with solar power, as you can see here with the sun. The second one is value cycling. So nature figured out a way to reuse materials in evolutionary growth and development, so continuously cycling them up. And the third one is material simplicity. And into this rule, we look a bit more into detail now. So here you can see the elements in the periodic table, as you all know it from school. And these are the building blocks for everything we see in the world. Surprisingly, however, out of the more than 100 elements nature chooses to use just 4. Carbon, hydrogen, oxygen, and nitrogen to produce all living things. Add a little bit sulfur and phosphorus, and you can account for 99% of the weight of every living thing on the planet, including us humans. And with these 4 Maya polymers, nature can create something complex as a flying bee and manage to recycle because of simple material choices, as we have learned before. Whereas we humans use many more polymers, and this makes recycling then so difficult. And yeah, with these simple polymers, nature has everything what it needs and is still able to create something complex as a bee that is flying. It is interesting to understand how nature achieves such complex objects with simple materials. So nature does this by adding functionality to matter. So it adds structure to matter by following actually an additive manufacturing process. Layer by layer, life is built to shape, and the complexity and stability comes through the design. And nature's simple palette results in products far more advanced than those produced by human industrial science. So as you can see here, seashells that are twice as tough as science's best ceramics. Spiders can spin silk that is stronger than steel, yet light enough to float on the wind. And nature suggests that the potential for inventive uses of easily recycled materials is huge. The abalone, for example, took some very humble materials, chalk and proteins, and made something a lot tougher because the way these weak components are structured result in a material that well outperforms its individual components. So bricks are shaped in a very particular way. They are wavy. And nature uses these simple basic components but fits them so skillfully together that quality material results. So it's above all design that makes intelligent materials out of these basic ones. And that brings us to 3D printing, a technology that allows us to create objects that are as complex but also as efficient as nature. And within the last 30 years, 3D printing has developed further. So long time it was used mainly as prototyping, but now 3D printing stands on the transition to manufacturing and is used for end products. And with more and more computer power and new technologies we have available, the better we can design and create objects like nature is doing it. Just to give you an idea, this is the first fully 3D printed electric car, and it's available to order now. It costs around 6,000 euro and you can make your individual car because you can personalize the parts. Here you can see another 3D printing example of the University of Singapore. So they printed actually a material called flam, and this is made of the 2 most abundant components on Earth, cellulose and chitin, and printed this 1.2 meter air turbine. And flam is strong, scalable, but still lightweight, and it is biodegradable and inexpensive as it is about the same cost as commodity plastics. So it is possible to make even technical products from natural materials. But how can we mimic nature's recycling process? Let's see how this could look like for plastics in a circular economy. In a circular economy, fossil plastics are replaced with bioplastics, so we can avoid plastic waste in the first place. Bioplastics are made from biomass, such as green waste from a local farm, directly as material or indirectly as energy. The other way around, biomass can be made from degradable bioplastics, even if it is contaminated with food. So clearly, this cycle is renewable. But is there also enough biomass available that could be used for the mass production of bioplastics? The answer is yes. Every year, nature produces 2,000 billion tons of dead plants in form of cellulose and lignin. This is more than all plastics ever produced since 1950. In fact, the very first plastic product was a billiard ball made from cellulose in 1860. Even the first Lego stones in 1949 were made out of cellulose, but also because of cheap oil at that time, we simply ignored cellulose and biomass as a sustainable source for bioplastic materials. But can bioplastics be made only from cellulose and lignin? No, not only. Next to cellulose, there are other renewable bio-based feedstocks. So agro-based feedstocks such as corn or sugarcane, or organic waste feedstocks. And all of them are a source for bio-based products. are not only compostable products, but also for long-lasting, durable products like a yoga mat or a tablet. Today's material suppliers could replace 85% of our fossil plastics with bioplastic alternatives. But why isn't this happening already? Beside a current lack of economies of scale, our research shows that more than 80% of consumers do want to buy eco-friendly, but they don't know what bioplastic products to buy from what manufacturers. The same is true for an estimated 70% of manufacturers who don't know what bioplastic materials to buy from what supplier. And this is something I also made my personal experience while working in the 3D printing industry. So often when talking to the manufacturers, they were very interested in the biomaterials, but they mixed up a lot of things. So for example, they thought that bioplastic always means compostable and other facts, but this is absolutely not true, because there are many materials that are very durable and strong, as you have seen before. So to solve this collective lack of knowledge, we as Secretaria are developing the fantastic Bioplastic Finder, an online platform that matches suppliers, manufacturers, consumers, and recyclers by promoting and informing about bioplastic materials and products. The environmental impact of our platform can be huge and multiplicative. So we can contribute towards a circular economy that replaces fossil plastics with bioplastics and thus reduce plastic waste and burn emissions like CO2. Currently, the bioplastic market is very low at around 1% of total plastic production because of yet undeveloped economies of scale and the low price of oil. Within the next 10 years, however, bioplastics will grow up to an estimated 18% of market share. There are many drivers for this change. So one of them is policy engagement. For example, the European Union just agreed on a plastic tax for all non-recyclable products. And this is just one of the measures towards a circular economy. Another one is corporate vision. Lego announced that by 2030, it will produce all products from renewable plastics. And scientific breakthroughs make bioplastics competitive not only in price and sustainability, but also in materials properties. So to summarize my presentation, the plastic problem only gets more serious, but it's not realistic to live completely without it. So we need new solutions that are embedded into the circular economy. And there's clearly no silver bullet, and recycling will not be the only answer. Actually, within the circular economy concept, recycling is really only the final step in a completely transformed industrial process. And the most impactful aspect of the original circular economy concept is redesigning products and industries from the start to be non-toxic and safe, using as much renewable energy and biomass as possible. And yeah, with new technologies like 3D printing, we have now new opportunities to design like nature, and this we can do by using less and simpler materials made from biomass. And last but not least, we need the support from policy and corporates to accelerate the circular economy, especially for materials made from renewable resources. Yeah, to end my presentation, I want to thank in particular the MacArthur Foundation, where I did a 10 weeks course about the circular economy last year. That was very valuable. And I also want to thank European Bioplastics for our continuous partnership. And of course, a great thank you for your attention. If you want to learn more, you can visit secretaria.com. Thanks and enjoy the rest of the event.